Good afternoon, physical geology students. This afternoon I was talking about the Earth's interior. We were getting into a little bit of geophysics. We were talking about the geothermal gradient within the Earth and the magnetic field as well. And we left off on gravity measurements. So I want to kind of briefly just talk about what does this mean? And a gravitational force between two objects. For instance, here you could have the Earth or you could have the Earth and the Sun here, A and B, and it's determined by their masses and the distance between them. So there are gravity meters, and it's an instrument that we can place on the Earth's surface, and what it does is it detects basically the tiny changes in gravity, at one point, and essentially you can have if you have a positive gravity anomaly, and that's typically if you placed a gravity meter over, let's say, a large ore body underneath in the ground, it's going to pick up a positive gravity anomaly. If you have something, and that has to do with the density of the material below. Also, if you have a negative gravity anomaly, that is going to represent something that's less dense. So you're talking about caves, water, magma, and different sediments, and also felsic rocks. So here's kind of a perfect example showing here you have a spring with a suspended weight on it, and here is the same situation, and it's showing you if you have a real dense metallic object or piece of metal underground, the gravitational pull is going to be much greater than it would with the limestone rock here. And also, it's going to pick up, this is a cave. So it actually is, it's going to be even less here with this hollow space in the rock. And over here, it's showing you kind of what happens is when you get a positive anomaly. So here, it's showing, again, you're going to have a positive gravity anomaly here. So you're going to have continental crust here. It's going to show a positive anomaly here. It's because it's pushing up here as well. And then here it's pushing down. So here it's showing where you have a negative gravity anomaly. So that's just kind of giving you an example there. So here's basically the Booger gravity anomaly here, and it's measured in milligals. And it's showing here you have a very low gravity, negative gravity here, and you have a real high gravity anomaly here. And this makes sense because this is the mid-continental rift that basically goes all the way through, through Kansas, Iowa, Minnesota, and all the way up through here. So remember that the rocks here had a very, very high magnetic strength. They were very magnetic rich. Very magnetic rich materials, and here it's also going to have a very high gravity anomaly. So basically your magnetic strength maps and your gravity maps usually coincide. Usually if you have a high magnetic anomaly, you're going to also have a positive gravity anomaly in that same area. So this is a nice kind of map of the Midwest showing here. Look at this. This is in blue. This is the ocean basin that was once in Wisconsin. Remember that we were quite a few million years ago. We used to have an ocean in here, and this is probably a negative gravity low here. So that kind of wraps up the lecture on the Earth's interior, and I believe what else? It was Earth's interior and earthquakes. So I'll talk to you guys next week, and we'll get into geologic structures and what is it? The last thing, and mountain belts. Okay, so I'll talk to you soon. Bye.